Okay, if you could get out the second half of the lesson yesterday, from yesterday. What was the order that I needed you to do transformations in? What had to come last? Alexis, louder please. Okay, you have to move last. And we're going to explain, I'm going to show you a video, or not a video, I'm going to walk through why if you do the translations first, you end up with a different graph than what may have been required. Now, I can do transformations in any order I want, but that's not going to give me the equation that may be shown. Okay, so if I give you an equation, that means the transformations are in a certain order. The way of doing, or if I say translate this graph and then find an equation, that's a completely different story. So, as I said, SRT or RFT, I don't really care as long as the T is at the end. Now, let's say we are given a graph and we are given the equation of the graph. In this case, it is an absolute value function. And we have done some type of transformations on it. The easiest thing that you can do is pick a point and find the moves. The moves are easy to figure out, particularly on this graph. Okay, we went from 0, 0 to 6, 2. So we can basically state the move, moved it 6 left, 2 up, by finding a very easily identifiable point. And to me, that's usually peaks or valleys. Now, so we can take this and we can modify this equation to this. Okay. Now we have to figure out the vertical stretch and the horizontal stretch. Well, in this case, I'm going to find one. I'm going to say either I stretched it vertically or I stretched it horizontally. I'm not going to do both because that's too much. Right now we have two unknowns and we have a couple points here, but they don't really help us. All we need, if we change this equation to we just say, okay, I'm going to assume that this graph, all it did was vertically stretched. We can see it wasn't. Has everybody got these notes?
Yeah, I've got them, I just don't, yeah. Sorry.
So here we have, we made a choice. I made the choice to say it was vertically stretched this time. By eliminating the second unknown, the second variable b, I've made this solvable. I have 2 points up here. We can't use this one because we've already used it for our move, but we can use the other guys. We went from 4, 4 to negative 4, 7. So I'm going to take this point, which lies somewhere around there, lies on our new graph. I'm going to plug it in. Y is equal to 7. And plug your negative 4 in for your x. Seem to have run out a bit of a room here. We have 5 is equal to a times the absolute value of 2. The absolute value of 2 is just 2. So a is equal to 5 over 2. I just dropped the brackets when I moved it over because it's an absolute value. So one possible equation for this is y is equal to 5 over 2 absolute value x plus 6 plus 2. Now, that's one possible. That's basically saying we stretch this vertically by a factor of 5 over 2.5. So we stretched it like this. We picked it, or we stretched it, and then we moved it. Again, the order. Because we created the equation that is defined by our order. We always do our moves last if we have the equation. So I've taken this graph, stretched it this way, and then moved it over and up. I could have just as easily, and I'm going to do it again over here, say no. I'm going to say B. And I'm going to solve for B. Now, I could have picked the other point quite as easily. I could have picked this point here. 7 is equal to B negative 8 plus 6. So we are actually going to get the same, I'm sorry for running out of room. We're going to get the same equation, or same number for B. Where can I go? I guess I can go over here. Now, we're going to have negative 2b in the brackets. Absolute value says ignore the negative sign. So now we're at equal to 5 is equal to 2b. B is equal to 5 over 2. Now, what's different about this? Well, here we did a vertical or a horizontal stretch by a factor of 2/5. So we end up with the same number, and that's the property of the absolute value function. You're not always going to get that, but you will the absolute value function. And we're going to stretch this way first and then move it. And you'll see that, like last year when you did quadratics, you only ever talked about doing a vertical stretch. Right? You always talked about quadratics are always in the form y is equal to a x minus h plus k. That's your vertex form for your quadratic. So you always said it was stretched vertically. You can, and we will talk about it, horizontally stretching. Now, not numerically, they're not the same, but you can stretch it horizontally and then move it. Or you could do both, but it's just easier to apply one stretch to these ones. And I am sorry about the lack of space. Here's a quadratic. Here's our base quadratic, 0, 0. Now you should be able to get, because this is exactly what we did last year with quadratics, you should be able to get the new equation. We started with we're going to talk about the moves. But first, because we can get the moves easily. The move went from 0, 0 to 3, negative 4. So I moved it 3 units to the right, 4 units down. And I'm deciding, because this is what we did last year, let's find the vertical stretch. Now, what do we know about that value for A? You can give me a very generalized part for this A. Started this way, ended up that way. What do we know about A? It's going to be negative. Now I could put the negative in there right now, but we should get the negative out if we do this properly. So pick one of these points I'm gonna pick the 0.5, -7. Every place I see a y, I'm gonna plug in -7. Every place I see an x, I'm going to plug in 5. So add 4 to both sides. And we have 2 squared. Solving very quickly, squaring 2 and dividing by 4, we have a is equal to 3/4. There is, again, one possible stretch for this. Okay. Now, we got out a negative, which is a good thing. Now, I cannot just apply a horizontal stretch to this because I know I have a reflection that I have to deal with. So if I wanted to find a value for B in this case, my equation that I would start with, oops, that's not what I want to do now. Okay. So here, I have to put in a -1 because I know I vertically slipped it. So that's where that negative comes from. But I can get a B value out of this. That's different than that. So here we had the 2 moves and we knew the reflection. We don't know how much the horizontal stretch has been. Again, plug in your values. Pick a point other than the 3, -4 that we used to start with. Pick a point. We could pick 1, -7 or 5, -7. Doesn't matter. Now I'm going to add 4 to both sides, gets me to -3. I'm going to divide both sides by -1. Now I could square everything, but I'm just going to take the square root at the moment. Okay. Now, okay, can we put the phone away, Sean? You actually had it out. It's way too much. Take the square root of both sides. Plus or minus square root of 3. Because we always have to take the positive and the negative. We may be able to ignore it later on. We are in this case. B is equal to plus or minus the square root of 3/2. Now, why can I ignore the negative here? Well, looking at this graph, notice the graph is symmetrical around the y-axis. So the fact if I flip it this way, it's going to be the exact same graph. So I can ignore the negative in this case. So this and this equation are the same. And I'll prove it to you in a second once you copy everything down.
Oh, no, never mind. Just the 2 flipped into this one, so I thought it was the square.
Yeah, no, that's,
Yeah, I do it.
I kind of wrote they're too close. So the process that you do when you're asked to identify an equation is because you can't actually solve to figure out, so you can't algebraically solve to figure out if there's two stretches. You can only solve for one. The moves are fairly easy. They're usually a point that we can see. But here we're looking for one stretch. Pick one. Now the question will probably, if it's a multiple choice, it will ask you which question. Which one? Now, I said I'd show you that these two questions are exact, or two equations are equal. I'm going to start with, you don't have to write this down. I'm just going to start with this. This square applies to both terms in this function. What happens when you square square root 3? You get out 3. So we have 3 over 4. And then I can just drop the outside brackets there, because they're not really doing anything. Or I'm sorry, maybe not drop them, multiply the -1 in. And you have the exact same one that we did with the A value. So algebraically, we've shown that these two equations are equal to or the exact same as each other. Now, going back to what we finished with yesterday, we did a transformation in a particular order. We did a stretch, then a move, then another stretch. And we got this equation. One of these two equations, doesn't really matter which one we got. Okay? So if I do it to these values, which is on my graph here, and I apply a horizontal stretch by, a vertical stretch by 2, vertical stretch by, what the heck did I do? I did a vertical stretch by 1/2, didn't I? Oh, shoot. Damn it. 2, 4, 2. Oh, that's not right. Okay, we got to fix this because I messed up again. It doesn't actually affect too much. 4, 8, 2, 2. And these guys got to be changed also. So I will fix my graph in a second. I just moved it to the right 3. So that should be 4, 8, 2, 2. So all the y values are 4, 8, 2, 2. And mess up on my part. I vertically stretched the wrong way. But we watch at our x values. We move it, and then we stretched it. So we have the point 0, 4. We have the point 1, 8. We have the point 4/3, 2. Be right about here. And we have the point 2, 2. Now, if I was to look at this graph, and I think about the order, I'm going to vertically stretch it first, then I'm going to horizontally stretch it second, and then I'm going to move it over. I'm only moving it over 1. Okay. So if you think about this graph, that new graph I've got drawn, if I first stretch it, down here, yes it is. I do have to fix my values for my y values again. So if you think about what I do here, if I horizontally stretch it by 1/3, then I vertically stretch it, which I should have done in the first place, which I should really fix. Okay. And then I took it and I moved it 1/. I end up at the exact same points that I have up here, down here. Okay, and I am going to fix this with my 8.22. Okay. So, two stretches applied in a different order. Two of them are the same. Stretches are the same, but the move is completely different. Up there, I moved it 3 to the right first, and then horizontally stretched by 1/3. Down here, I did my horizontal stretch by 1/3, and then my vertical stretch, and then I moved it 1 to the right. How does this equation, so here's the equation. Okay. So here's the equation that I would do with this here. Y is equal to 2. 2f of, I'm so used to having my fingers erasing. That's the equation that I would get. Vertical stretch by 2, horizontal by 1/3, 1 move. How does this equal, because it's the exact same graph, how is this graph, this equation, exactly the same as this equation? Or more likely, can you make this equation look like that equation? Now, what can you do? Well, I see a common factor of 3 here. And if I take that common factor out, I end up to here. And that's what I'm going to need you to do, is take a look at inside, basically anywhere like this, and write it in factored form before you give me the transformation. You will get those 2 stretches correct. But you won't get the moves correct unless it's written in factored form. Okay, so we already, and I said, how they do. You have to take this equation and make it look like that before, if you follow the stretch, reflect, translate. Now, because I've been doing this so long, I can look at that guy and go, okay, well, it's vertically stretched by 2. Oh, they moved it 3 to the right and then stretched it by 1/3. But I don't expect you to have that yet. That's the only reason I've been doing that. How many years I've been teaching this particular course? 13, 14. So keep that in mind. So when you are given something like this, these are not in factored form. This is not factored, this is not factored. Okay. And I'm going to show, I'll put one other one up there that I saw that I haven't actually done. Before you give me the transformations, take this guy and go, nope. What would go here? If I took a common factor of 2 out from this bracket, what's left in the new bracket that I've got there? X minus 1/2. Now go ahead, because we have everything in nicely factored form, we can go ahead and read that. We have a vertical stretch by 3. I'm going to be lazy and not put the lines. Horizontal stretch by how much, Alexis? 2 or 1/2? The horizontal is 1/2. It's next to the variable. And then we go 1/2 right, 2 up. You would get 3 of the 4 correct if you had not factored it, but you would not get the 4th. Again, here, we've never talked about a logarithmic function. Doesn't matter in this case. Okay? Logarithmic function looks like that. Now you can apply the proper transformations because I've given you the graph. We will talk about the logarithm later. Again, this is not written in factored form. Take out the 1/4 as a common factor. So that's going to leave you with x. Now, when you divide 2 by 1/4, what do you get? You get 8. 2 divided by 1/4 is 8. So now, if we are going to do it in the order that we've been talking about, we have a horizontal stretch by 4, and y is equal to 0. And we move 8 right and 4 up. You will get the 8 right or wrong if you don't take out a common factor. I am just going to put a negative sign here, because this is a mistake that we make fairly often. I'm just going to put it in there. So, again, never talked about a sinusoidal function. Don't know what the graph of sine, well, actually, you probably do know what the graph of sine looks like. Mrs. Lowry may have showed it to you last year. But again, look, it's not factored. Let's make sure that we actually do factor this. 3 doesn't do a dang thing. Sine, take out a -2, that gives you x. We have pi over 2, and we'll leave it as pi over 2. What happens to the sign in between those? Changes to a positive, because we're dividing negative pi by -2. And what happens here is we occasionally mess up and forget that sign change. So again, once we're now here, vertical stretch by 3, horizontal stretch by 1/2, reflection in the y-axis, negative. And then we moved it pi over 2 units left. And remember, that's a number. 1.58. Something like that. Pi over 2 is the exact formula. And then we have 2 up again. Now I want to put one more on here. Okay, so in this case, neither of them are factored. Right? And we don't want to, if we just ignore the fact that this is not factored here, we're not going to move it up the proper amount, and we're not going to move it to the left or to the right the proper amount. So here we're going to take out a common factor of -3. That gives me y plus 2. Take out my 2 here, give me x plus 3/2. Yes, I like writing fractions. You want to put 1.5, you cause me grief, but it won't mark it wrong. So let's talk about what transformations we've got here. You should be able to look at this equation in this form and work through it. You can move all the stuff over here and make y equal something, but you should be able to look through this. We have a reflection in the x-axis, because we have a negative y value. we have a vertical stretch by, is it, in this case, it's next to the y. Is it by 3 or by 1/3? By 1/3. It's next to the variable. We have to take the reciprocal. And we can see this by dividing by 3. We'd have 1/3 on this side if we were to do that. Okay. So over there we have a vertical stretch by 1/3. We have our horizontal stretch by 1/2. And then we have 2 down, because it's y minus -2, and 3/2 or 1.5 to the left. So again, when this shows up, make sure you factor. This is a level of excellence question that everybody in this room should get. You guys are not, like it's put as a level of excellence question. You're only going to have 2 or 3 of these type of questions on the exam. If you get this one, because it is relatively easy, one more bonus for everybody. Okay, and this is, again, 2 different ways of asking the question. Here I've given you a point, and I want you to determine the new point. So watching what we have, the point lies on the graph f of x. That's my starting point. Okay, because it lies on the graph of x and we're manipulating f of x. Now, before I go ahead and figure out my transformations, let's make sure that this guy's written in the proper form. They go to common factor of 1/2. Close my bracket twice and add 5. So what's the first transformation that you want to do, Aurora? Okay, so we're going to vertically stretch this by 2 to give me my point, -12, -12/36. What's the next one you have to do now, Rory?
Horizontal stretch.
By?
2.
Horizontally stretch it by 2. So that means we're multiplying the x coordinate by 2. So we have -24/36. And then we can do the moves at the same time. We're going to go 16 right, 5 up. So 16 right with -24 is -8. 5 up is 41. Do you see how the next one is different? The point 0.06 lies on this graph. That's where we want to end up. That's where we want to end up. That's on that graph there. We have to make sure we do it right. So first step, I'm going to take out a common factor 3 here. The exact same thing as I did before. So I have to factor this one and I have to factor that. So what's the first transformation? First one for me, I'm gonna write down is a vertical stretch by a third, horizontal stretch by 1/2, and then we are going to go 2 up, 3 left. Oh, to get to 0.6, we went 2 up. Okay, well then I must have started at 4 and 3 left. So if I started at 3, 4, I went up 2, I would get to my 6, and if I went left 3, I would get to my 0. So here's my transformation or my translation. What did I have to start with to get to here? Horizontal stretch by 1/2. I don't care which order these ones come in. I am going to run out of space if I'm not careful. Well, didn't do anything vertically, so the 4 stayed the same. I horizontally stretched by 1/2 and got to 3. Where did I start? I started at 6. And then I have a vertical stretch by 1/3. So 6 stayed the same because I didn't do anything to the x coordinate. And well, what times 1/3 gets the 4? 12. So this is that working backwards idea. What are the stretches, or what are the transformations? Always start, well, if you're working backwards, your transformation, your move, I should say, is always the last one you do. So we started at 6/12, vertically stretched by 1/3, horizontally stretched by 1/2, and went 2 up and 3 left. Are there any questions on this? There is your home whiteboard work and your homework. So in textbook, you have 3 questions, and in the homework, you have quite a few more. So I believe I attached both the iWrite and the Pearson workbook. This. Okay, so the iWrite questions are here. They're back on right behind yesterday's homework, and then the Pearson workbook is right here.